So, hello everyone. I'm George Michelson from APNIC, and this is the Wednesday morning technical session. We have three presenters today. The first one up is Jordi Paulette, who I think all of you will know because he's been in our policy process for many years and also done work in training at APNIC and Apricot presentations. And then we have two separate talks from people at Hurricane Electric on different aspects of the network. Jordi, you ready to rock and roll?
Thank you.
Okay, so center button, laser pointer, let's move.
Thank you. Okay, so if you expect me talking about IPv6 today, this is not about IPv6. I'll still call it a new internet, but it's a totally different thing. Oops, sorry, go too fast. So my talk today is about HTTP2, QUIC, DOH, and something else, okay? The thing here is, during the last years, internet has been changing in the sense that more and more traffic is moving away from many protocols, many ports, to everything HTTP and HTTPS. So it's port 80, port 443. Up to now, only DNS was not yet using so much HTTP, HTTPS, but this is also coming. This is changing very quickly. Well, why this is happening? Basically, many networks are filtering whatever they don't know. There are many networks, many hotspots, hotels, and things like that they filter whatever they are not able to understand. So they just reduce the chances to use 80 and 80 and 443. And of course, the advantage is that by improving just those two protocols or those two ports, we can greatly do quickly changes in internet and enhance performance instead of requiring looking into many other different things. That's the thing. So there is more a perception about the need for security, for privacy. So this is also helping to concentrate in a few ports or protocols to achieve that, right? So the history about the change from HTTP 1.1 to what it was initially called SPDY started in 99 was HTTP revised to the 1.1 version, that is the one most used today. And since then, many websites have changed. At the beginning, there were a few objects, few kilobytes, and now obviously is many objects, many megabytes. So this required a change. In 2009, Google posted about a project that at that time they called it SPDY, which basically was doing multiplexing across a single TCP connection. They also were using compression to reducing the HTTP headers, and prioritizing some of the assets of the web page, right? There was also the possibility to do a server push, so the server can push some specific resources to the browser even before they were requested. SPDY at that time was designed as a tunnel for HTTP in HTTPS. It means it requires, of course, support in both sides, the server and the browser. And in 2016, I have not been able to look for more updated figures, but in 2016, it was over 90% of the worldwide traffic already. Is using what they call it the next protocol negotiation to negotiate the SPDY with the TLS servers. Now, in 2012, the ITF HTTP BIS working group used SPDY as a starting point to produce the HTTP2 protocol, which has been approved as a standard, RFC 7540, in 2015. The main difference is that HTTP2 does not require HTTPS. However, the reality is that all the browser vendors implemented HTTP2 only with TLS support, so with HTTPS. So that's the reality. This is not actually a problem because we have systems like Let's Encrypt that allow you to have in your server at no cost HTTPS support, right? So it's not really a problem. Another difference is that with TLS, instead of using the next protocol negotiation, HTTP2 is using what they call ALPN, Application Layer Protocol Negotiation. There are earlier implementations that supported NPN because compatibility with SPDY. And the main difference is who is deciding what protocol to speak. So in NPN, the client was making the choice, while in ALPN, it's the client gives the server a list of supported protocols, and the server picks one. There is a global support for implementations of HTTP2, so that's really widespread. I have been looking yesterday at figures about how much usage of HTTP2 is over there, and it seems it's close to 30%. Okay, I put in the slide the URL where I pick up that figure. Well, if you look at the number of top websites, actually the percentage is much higher because most of the big websites are using today HTTPS, so that makes it easier, right? So the figures are relative to what are you looking for, but in general, I think it's a really good adoption in general. So this is a very simple figures that explain what is the difference between HTTP 1.1, HTTP2, how it's working the multiplexing. I didn't make those figures, are also taken from a popular website that talks about this topic. Now, what is, if we want to summarize technically HTTP2, what is basically, it's a binary protocol. It makes easier the framing. It has different frame types. However, the setup is the same for all of them. And there are right now 10 different frame types, including 2 to map the HTTP 1.1. It has multiplexed streams. Each stream is an independent bidirectional sequence of frames exchanged between the client and the server, and offer different features like priorities and dependencies. There is also the support for the header compression, which is called HPAC. There is a way to reset the connection. There is also a server push that I mentioned already before. It was available in SPDY. And there is also flow control. Okay, so that's the main features or the main things that we can find, technically speaking, in HTTP2. If we want to see a summary view of this protocol, we have one TCP connection, the request for the stream, the binary framing layer, and then the HPAC for the compression. Okay, so that's basically it. There are also some extensions. Basically, the client and server can negotiate new frame types on a hop-by-hop basis. And there are also what they call alternative services. I am not going to go in deep onto them. We don't have enough time. I look at also, and in fact, I have been using HTTP2 since several years ago. So I look at very simple ways to implement it. So if you are using, for example, Ubuntu, a server which is 14 or higher version, which Apache 2.4 or higher version, you can just follow the instructions that I have put in the screen, and there is a repository from André Souris that you can use to keep it updated. Very simple way, and it's quite easy. So basically, you don't need to do your own compilation or anything like that, and you just need to make sure that your virtual host have support for HTTPS, and the directive protocol H2, H2C, HTTP 1.1, so you support all the possibilities. Okay, so that's basically it. I did that myself because I am not using NGINX, but I look at also the configuration for that. So here you have the instructions for setting it up, and I check it with people that confirm it to me that this is working. So here you have it. There is a small demo if you really want to see what is the difference between HTTP 1.1 and HTTP 2. There is 2 ways to see the demo. There is a YouTube video, is the second link in the screen, and another link which is actually a live demo for that. And I am going to ask okay, so if you reload, can you please reload the screen? Okay, you see the difference in how much it takes to load one or the other. So it's about 2.5 times slower with the regular HTTP.1. Thank you. Okay, so there is also a Chrome extension which is called a speedy indicator, HTTP2 and a speed indicator that allows you to see if a web page is supporting any of those protocols. Okay, so that's for Chrome, and there is something equivalent also for Firefox, which is called just HTTP2 indicator. So that's very useful extensions that you may be interested in checking on. QUIC. This is one more protocol. During the speedy development, it was obvious that TCP is not sufficient for most of the actual internet usages, so they started also to work, again Google, in what they call it QUIC UDP internet connections. So the working group QUIC from ITF in 2016 started to develop a UDP-based stream multiplexing encrypted transport protocol. And the initial case for this protocol is just HTTP over UDP, but it's open to other usage cases. If you look at some stats in different places, it seems that basically it's Google who has implemented it, but it seems that also Akamai has some implementations. So actually, it looks like about 12% of the internet traffic is already using QUIC. QUIC standard requirements. QUIC standard requires encryption. It's using TLS 1.3 to establish the session keys and encrypt all the packets, including the ACKs. The actual draft, which is version 14, and I think it's going very, very soon to the last call, so it may become an RFC in a matter of few months, I guess. Only few parts of what they call the short header are used for all the these few parts of the short header which is used for the packet exchange are not encrypted. Okay. The thing is that this encryption of almost everything disallows the passive RTT measurements. So there is one more draft, which is called the flip bit, which is looking into ways of doing that. It's considering also 2 options, just 1 bit or 2 bits. So this is still quite open to the discussion, and we'll see what happens in the next months. If we compare HTTP versus HTTPS and QUIC, we can see the difference in the connection establishment. So for example, after the first packet, you can get with QUIC a 0 RTT, okay? So it gets really impressive. What is QUIC? In short, it's transport over UDP, typically implemented in application process, not in the kernel. The functionality is equivalent to having TCP plus TLS plus the streams. It includes support for TLS 1.3 and enables 0 RTT. If we compare, again, HTTP 2, which HTTP and all the options, that's what we get, okay? If we compare HTTP 2 with QUIC, we have this picture. So we can see that TLS 1.3 is already part of the QUIC process. How you can implement QUIC in servers? In this case, I didn't try it myself, but I found a website that explains how to do that in Apache. And there is a website also that is tracking the status of many other implementations. So if you want to take a look or take the risk to implement in a production server, well, I'm not sure if it's at this time a good idea. In the case of HTTP2, I was doing that even for my production servers, but after it was stable for a few months. So maybe here is the same thing. You want to start with some testing and then go to the production servers. DOH. There is one more word related to all this, which is DNS over HTTPS. Is being carried out by the DOH working group in ITF. Basically, it's enabling DNS to work over paths where existing methods have issues like UDP, TLS, DTLS. The transport is suitable for traditional DNS clients, for native web applications that use DNS, and is only using HTTP2. So this is very relevant because it means that, of course, most of the websites are going to implement HTTP2, but they really need that to do DOH. It's not just a tunnel over HTTP, it's establishing a default media formatting types for requests and responses, and is using normal HTTP content negotiation mechanisms for selecting alternatives that endpoints may prefer. There will be also, or is open also to future user cases. It's aligned with the features of HTTP, and basically you can see that as a way to avoid authorities to restrict access to certain contents to citizens, right? So that's a simple way to understand what is the result of implementing DOH. There are also some generic tools and implementations. I have listed here some websites. There is also a proxy DNS functionality for using fast CGI endpoint and a DNS proxy server. So several things that you can try as well if you are interested. There is also a website where developers are exchanging information regarding that. And this is how we can progress a little bit more with DNS over QUIC. This is one more work, which has right now only one document, which is draft UTEMA QUIC DNS over QUIC. Right now it's version 05. I looked at it yesterday. And basically, this is looking to transport, well, we are using QUIC as transport over UDP, and typically implementing also the functionality, as I mentioned before, of TCP, TLS of streams, including TLS 1.3, and then it's just doing the DNS also over this protocol, this transport, okay? So it's a very high performance transport, and in fact, if you compare the different options, you can see how QUIC can perform there to transport DNS as well, right? So, HTTP2 is reducing the number of round trips, avoiding blocking by means of the parallel streams, and allows discarding unwanted streams. So it's, in general, much faster and better web experience for users. De facto, it requires HTTPS, but there is not a big problem today because we have tools like Let's Encrypt that allow any web server at no cost to support HTTPS. Regarding QUIC, decrease the latency, avoids packets loss, blocking all the streams as it happens in HTTP2, and makes connection possible with different interfaces, mobility, flopping, etc. DNS over HTTP can avoid DNS failures and some censorship. DNS over QUIC also provides DNS transport privacy. Okay. How much of this will be important for non-web traffic? Well, if we see that more and more applications are also using HTTP and HTTPS for non-web traffic, obviously there is a big impact here as well. And I think that was my last slide. I'm not sure how I did with the time. I lost track of the time here. I like having the counter, you know?
So you actually have done very well because we only have 3 presentations in a 1.5 hour slot. We have lots and lots of time for questions if people have any to ask. And I see movement towards the microphone. Please state your name clearly.
Jeff Houston, APNIC. Geordie, I don't think you touched on the one thing about QUIC, which is truly a massive shift in our architecture of end hosts on the internet. TCP is normally not implemented at the application level. It's a function of what we'd call a kernel. So all the applications running in a host will share a common view of TCP and end-to-end flow control. QUIC lifts congestion and flow control from the kernel to each individual application. What Google or anyone else can do when they use QUIC is negotiate an entirely separate congestion control algorithm that they want to run. And there's nothing the network operator can do about this. For example, if I wanted to run BBR, I can, and no one can stop me. Now, that's a kind of bland statement unless some of you run networks that have mobile users. Because the one thing about mobility is that bandwidth is not an infinite resource, and what they hate doing is watching users try and seize control of the network. What QUIC allows is precisely that. And so the real sort of debate going on, and it's a pity that the 4G and 5G operators, the emerging 5G operators aren't in this room, is that they regard everything you've said as toxic, revolutionary stuff that should never be allowed near their precious network. Thank you. So when you think about mobility and think about the reaction, what Google have done is taken the role that network operators did and made it impossible to manage traffic on their network. What happens now? What's your view of where this fight goes?
I am guessing, obviously, this is not going to look good for mobile operators, and maybe they decide to filter this. I don't know what they are going to do. They can actually they filter it. We'll see. But this is going to impact their networks, obviously. They will need to look into different ways to manage that.
Yes, well, this is where I'm getting to. Yeah. And one issue is, oh, it's Google, we're going to lose this fight. Okay, do what you want with my network, I'll roll over. Or I'm feeling like having a fight today, I'm going to filter every single damn bit of UDP I see, in which case, where do we go from here?
Yeah. We don't know. We really don't know. And who is going to win the fight? That's the question, yeah.
So I suppose, again, let me make one more comment since no one else is at the mic.
Yeah, of course.
What we're seeing now is battle lines being drawn between applications and networks. And maybe it was Snowden, and maybe it's the fact that networks leak like a sieve. Maybe it's the fact that networks are now being regarded as the enemy. And the application folk are now looking at networks and going, I don't like you, I'm not going to cooperate with you, I'm not going to expose anything that my user is doing when running my application. You can whistle for this stuff, but we're not going to expose anything. And by the way, you really are the enemy. I don't know how we got to this, but this is where we've got to. So the application folk are now regarding it, the network is hostile, lift everything out of visibility, encrypt the lot, and then say to the network operator, well, tough, you blew it, there's no coming back. It'll be a fun 5 years. Thank you.
It's going to be fun. The thing here is, do you want to see this as the right of the user or the right of the operator or who?
As I understood it, this is Jeff Houston again, the major motivation for QUIC was a feeling inside Google that the middleware that all you network operators deploy is making any rational view of the network fundamentally impossible. You've deployed so much crap out there that even TCP gets muddled with so badly that nothing is left. And QUIC kind of says, I'm taking all of this off the table. All your middleware investment, you might as well burn it. It's not going to do any good anymore. We're not playing with you. And maybe this is the reaction. This is the death of middleware as the network operators knew and loved it. Yes. Now, is it my right as a user to run applications that define middleware? I'm there, but I don't know how the network operators feel about this.
We'll see.
Yeah.
We just need to wait.
Thank you.
So, a fascinating conversation. Thank you, Jordi.
Thank you.
So next up, we have Martin Winter from Hurricane Electric. He's a researcher and he's been working on real-time BGP tools and he's going to talk about his experience. Martin.
Okay, good morning. So, let's see where this shows me a link.
So this gives you forward, back, and also laser pointer.
Okay. So first before I talk, just a quick intro who I am. Next to Hurricane Electric, also work on the FR routing, free-range routing. For the ones who are interested what that is, show up this afternoon in the lightning talks. I will have a quick introduction there, what's going on. But at Hurricane Electric, I do research stuff there. I look at it, the different things, what we can do so on BGP. And we try to see, can we do a little bit different monitoring or something than what already exists, or doing a little wider spread. So, before I go into the weird issues and stuff I found, I want to first give a quick introduction what that whole tool is. So you have an idea how to do it, and it's an available like service. You can go on the website and try it out for yourself. So I assume most of you are very familiar with a traditional looking glass. So this is something different. The traditional looking glass is more or less normally a single entity. Normally you see looking glasses for a single provider, and it may show the different locations for that provider, so you can see the view of the network at different locations, but a single provider. It may be for an internet exchange, and you can see there the view is different there. Also, traditional looking glass normally gives you more router output directly, not really parsed, maybe a little bit beefed up, like this example with like framed within a web page, but other than that, it's more or less a simple router output. So on the real-time BGP toolkit, we figured we want to look at this different. We want to make an addition, a different service. So the first key thing is like we don't want a single view. Think about now if you basically do just start picking up BGP feed from all over the world. And I'm sorry, I don't have a line from this island here, I noticed. I missed that somehow. I'm happy for somewhere later then to add some peer there. But the idea is really that we have, currently it's one location in California where we have the service set up. And we basically try to get eBGP feeds from like as many providers and as many locations as possible. So we are very open to interested to like see that you can join or something. So everyone is allowed to join. You can go to the web page, you can sign up there. It doesn't cost anything, and it gives you like some interesting benefits. So the idea is now when we have at one location, we can go look there back in the timing. We can like compare the timing, so you can see like how a route propagated across the network. Where did a route show up first? or like where did a bad announcement start. You can also, on route leaks, you can probably look at it. It also gives the main extra issue. It's not just from one view where you don't know it was intermediate, but you can also look at it from the sequence. And then obviously we're also looking at various bogus BGP announcements and trying to figure out that, especially the bogus announcements, they frequently get filtered out along the line, so they may like disappear a little bit. And especially if you're joining it, real-time notification for your networks, and I will get into this. Obviously, we don't just want to do that as like a single what is now. We basically say like, hey, we want not just the real-time, we want all the history too. So think about it that we take all the BGP packets from all the peers and we store it in one huge database. So we store basically every BGP update, every BGP withdraw in the database. So now this gives us like a few IDs. So we can go back and see like who announced a specific route previously, or from which AS, or did somebody leak a route just a few seconds for like some time back, or how the metrics changed. We can also go in there. Then the other thing is because we have like, we ask normally not just giving you your routes, we normally ask for getting us full routes. So we basically want to see the full, including all your transit routes, have them announced to us. So we can go and compare it. Because you may have like wondered sometimes when you talk to your colleagues like about how big is the full internet table. And he may say like, well, I think it's 710,000 routes. And you say, yeah, but I have 720,000. And like, what are the differences really? Which routes are not that well there? Or how are some of your routes propagating? Maybe some of your routes may be not visible all over the world. You can also look at the AS pairs, how they look like from the different. So you can enter a route and you see the different, how it's received, the different AS pairs from all these locations. Then another thing, especially when you're an internet provider or a small company, you can go create a login, you can register your routes on the system. So you can go in and say like, hey, this is my AS number there, and these are my networks. And I want to know if one of these networks suddenly shows up from a different AS. Tell me about that, because something went wrong or somebody doesn't like me. You also get notification if suddenly a more specific route will show up. So if you register a /16 and somebody starts announcing /24 within, you will get a notification on that. It doesn't require necessarily to be an ISP. So if you're a large company and you're concerned, but you don't really own the route, you theoretically can still go in, you can create an account and register the route and say like, hey, I'm interested in this route, send me notification there. And you gave an email address and it sends you an email if there's something changes. So as I said, so it's basically, you see, its main notification IDs for like hijacks. Hijacks on purpose or hijacks by accident, when there is like different source AS. There is also the more specific what happens, which could be it, or also some other various announcements. We are looking at a few more ways, especially for the hijack detection. We have some more IDs to implement down the way, but that's basically at the current time for the hijack. So, as I mentioned, it's basically the initial setup. The whole thing went live about April this year. So we have the first version online. We are working on several new versions with more features. So you can currently do some of the things like on a specific route. You can go look at the current paths and routes there. You can search like which peers don't have a specific prefix there. You can search for the AS numbers there, see what routes are announced there. And interesting for us also the unassigned AS numbers, which actually not just unassigned, it's also invalid one, reserved AS numbers and other things which shouldn't be out there. We also can show you some like timelines there, so you can see how the announcements happened in what sequence. There, as I say, the hijack detection and BGP play. If you're not familiar with BGP play, go look at it. I believe it was initially started as a project by RIPE. It's a really cool thing to visualize how a route propagated, how the network changed over time. And you can give it a time frame and say from like bit within this time and another time there, how it looked like. For the hijack report, next to the email, we also have a web page when you log in. So the hijack report is on a per user. There isn't really, at this time, a global view. We are not tracking that because it's not easy to know which routes are really going where. So it depends on the routes you go in and register. But you can see in there when you log in to your view, which says like, hey, these are the routes, which basically shouldn't be there. So this is just the test output, which I did there. But basically here, which ones are like wrong or shouldn't show up. Peer comparison, as I mentioned before, you can go compare the routes between IPv4 or IPv6 between different peers and see what the difference is. And the more interesting, I will get a bit more detail later in the talk when we talk about the interesting things found. The unassigned AS report gives you quite a long page. You can go look in there. And when you look at it, if I zoom in a little bit section, you can see like here, there's some highlighted AS numbers in there, which, hey, this shouldn't happen or something there. So this is like one specific like routes there, and you see like this number as an example is reserved, I believe, for documentation or something. So anyway, I'll get into it later. But anyway, so far from the tool, let's talk about some of the cool, fun things we ran into it. It's like just by bringing that whole thing up, there is lots of interesting things we found. We also have a very special our own BGP implementation, so we can like look a little bit more in depth into the details on not things which a normal router may ignore. BGP attribute 21. I'm not sure anyone in this room has ever seen it, heard about it, or ever used it. Hopefully not. But it never went above a draft state. The draft expired 11 years ago. So there should be no way it's out there. It was a long time back created as an ID to limit distribution of a route. It's a BGP transitive attribute, so it gets forwarded to the next router there. And it basically, you can limit it how many ASs your network should traverse. And if it hits that limit, then it will get dropped. The problem is obviously because hardly anyone implements it. You have now some routers who ignore it, and it's a transitive that just forward it to the next neighbor. And some other routers who may still have it implemented and they start dropping it. So you can imagine your reachability will be really getting weird. I saw that when I last looked there from about 3 different originated ASs. I asked them all what's going on, what they have. And interesting what I learned back, they had all the same firewall vendor, Palo Alto Networks. And Palo Alto Networks, as of the 8.1, I think it's still the current code, still supports it, documents it. Just if you have that, don't use it. It really does not help you. So, yeah, sometimes vendors seem to be a little bit slow to adopt. Broken 4-byte implementations. It's another vendor. Interesting things there. We basically, for the RTBGP, we use a 4-byte AS. There, and one vendor we had, he basically said he configured everything. The BGP open came, but it never had, so he tried to open, but he didn't have the 4-byte BGP option in there. And when we tried to open, he rejected as incorrect AS. And that was on a now extreme NetIron. And he looked at the config, said, like, everything looks fine. He mailed that to me, look, that's how the config looks like. And I looked at it like, yeah, that should be all perfectly fine. Nothing wrong. The interesting thing is on, on this product, you have to enable the 4-byte AS capability. And if you're missing that, it kind of works fine, except, so it still tries, you can configure a 4-byte AS, it still tries to open a connection, it just doesn't act like 4-byte AS. So you get no indication that you have not turned it on the 4-byte, and you can configure and everything, and it just ignores it. So no idea how that, how an engineer can think that's a good idea. Then we have the high unassigned AS number. That was something I looked into. It. Like I looked at unassigned AS report and then suddenly noticed this. And I figured, wow, these are large numbers. They shouldn't be there. What's going on here? The sad thing is, so far we haven't really figured out. The issue happened on a eBGP peer between NetIron, so that's Extreme basically again, and some Juniper router. It's a normal 2-byte peer, a 2-byte AS. We had different versions of the NetIron side there, and it all seems to be fine on that side. So different versions. It doesn't happen. It only happens with one other side, which I haven't managed to get contact yet and get an answer back from what's going on, what if they have a special hardware. But it seems to be some model of Juniper between a NetIron that they somehow mangle the AS pass by accident. And yeah, I'm not sure if you've seen that. I've seen that only with like one provider between one other provider who happened that so far. And you can clear it, everything is fine again, and then maybe a few days or a few months later, suddenly some of these come back and random different numbers. We tried many times to figure out if there's any logic in it, but we could not do. So anyway, enough of bashing vendors. Let's start talk about what some of you in the room may be doing wrong or something. So, you know these AS numbers, you're supposed to get them assigned to you and not just pick randomly. I hope most of you are aware of that. There are also numbers which are like reserved, like for documentation. It seems some people didn't get the memo and they're just using them. There are not private AS numbers you should use. They are basically really reserved. So you may want to look at it too. You may even consider like start putting a bit bigger filters in there. If you have somebody else you're peering with and he's sending that, maybe as an ISP talk to that peer and tell them like, hey, can you get your act together and clean up, please? So these are like documentation example. We have another number which is very common people use, 65535. People think that's a private AS. It's not. This is a reserved RFC 7300. So the highest AS number in the 2-byte and in the 4-byte, they are reserved. And the main issue is if you do the normal community format, where you have the AS number column and the community, that some of the well-known communities like the no export or the no advertise, they basically end up in that AS. So there are really weird issues which can happen if you use that. Again, that's something you should potentially consider filtering. Then we have other ones who just use random unallocated ones, which are still unallocated from the IANA list, so no RIA has them. And then you see the other ones down there, which two examples which look to me like a typo. At least they are not allocated and they just have an extra digit in there, and it seems that somebody is so lazy that they just make typos in the AS number and don't even notice it for months or years. But anyway, let's go to this region instead of talking about random world. Example, the last AS. Unfortunately, I looked at the attendee list. Unfortunately, nobody here from Vietnam, Vietnam. Any other Vietnamese people in here, maybe you can talk to them and give them a quick intro what that actually means. So it would be nice if that gets fixed. If you are one of the ones who forwards it, here I have at the bottom some of them there who accepts it. You may also really seriously consider filtering or as a peer or transit provider, use your power and explain them and have them changing it. Another one is in Hong Kong, Powerline Co. Hong Kong. I'm assuming it's them because that's the AS number in front of it, which I looked at it, so assume them or one of their customers. So definitely too, like you want to try to get them fixed. Then there are other ones who basically seem to I think the AS for documentation use is fine to use too, so 64,500. That's basically a reserved AS for documentation use. Again, it should not show up on the network. I did not go into all the ones who send private AS because some of them that might be, I always see that as a less of an issue. If you announce by accident the normal private AS, yeah, you may have issues, but at least you shouldn't cause problem for other ones who are clean with the filtering. So you probably only cause issues for yourself, but some of these, if they're ever like someone else, yeah, especially the ones who use completely unallocated, somebody else may start using them or getting them, and they will have serious problem. So that's mainly it. So the website again, you can go in there. We are basically looking we are very interested in getting peers. Our goal is really getting peers all over the world from like all the different views, so we can really have a good view where announcements show up, in what sequence. We are not just depending on the AS path or something. It's a pure BGP, it's an eBGP feed. You will not receive any traffic. It's a special AS just for that service. So I really appreciate for like any feedbacks we can get there too. So try it out, peer it, create an account. So if you want to peer with it, you go to the web page, you create an account, and then in there you can set up a peer. Please be aware that setting up the peer is not instantaneous there. I still do normally manual look at it within a day, maximum two, to look at it if it looks correct, because I worry a little bit about spam on people, random data they put in. And that's it. I want to point out, if you have questions over lunch, we have like Rick Payne back there too. He's just standing up there. He's one of the person who did a lot of the coding. Feel free to bug him over lunch. He knows a lot of the technical fun facts behind it. Or ping me afterwards too. So, but anyway, let's questions. Wow, I answered everything.
We're doing quite well for time, folks. We're probably about 5 to 10 minutes ahead of schedule. So if there are any questions or interest, we've got loads of time here on the floor.
If you don't ask questions, you are too early for lunch and you have to wait for the lunch.
Please state your name very quickly so nobody can hear it.
Jamie Gillespie from APNIC. Just wondering, with all of the mistakes and configuration errors that you're finding, have you tried communicating that to the AS owners? Or are you waiting for them to create accounts first?
Yes, some of them, not all yet. Some of the last ones here, which the Special Asian Pacific, sorry, I haven't contacted them directly yet, but that's still on my to-do list.
Yep.
But yes, definitely in general, yes.
Are you getting responses?
Sometimes, as I say, like the technical things, that was easy to get response. It seems people are more willing to answer when I claim it's probably a technical issue and I'm interested in, than when I claim that they probably fat-fingered or did something wrong. They seem to be less interested to respond.
Thank you.
But if anyone from APNIC wants to contact them, maybe you get a better response.
It's a nice idea, but we try quite hard not to go too far in putting external messages onto the AS holders. It's kind of a difficult posture to take with them. For instance, Jeff has been publishing and Phil Smith have been publishing for years and years lists of odd routing behavior, bogon lists, misannounces, and there's a level of interaction there that's just really hard to break through. People persist with very silly configs, but it's lovely to have toolkits that can see these things and expose these things, and I think the more we have visibility of it, the more likely it is we reduce.
Yeah. Maybe we need to add another function that we just mail that out to the correct AS person like every day or every week until they fix it.
It'll look like spam. I see a movement to the microphone. Please whistle your name in Bodot code.
Yeah, right. I think part of the issue with bad AS numbers is actually it doesn't matter. Insofar as I see at least 7 folk who camp on AS1, there are 5 who camp on AS2, and so on. Now, the only real consequence is that it is possible, but it probably doesn't actually happen. They can't see the University of Delaware. And even the reason why they can is actually because of the use of default. So we go after bad ASs because it's easy, not because it's consequential. The real problem, as far as I can see, is not bad ASs. They just really don't matter. Bad prefixes matter. Because as soon as you start announcing address space that isn't yours and might be someone else's, at that point, real issues emerge that are really a problem. Now, tracking that is difficult because, as you're probably well aware, sometimes that prefix isn't the issue, it's its aggregate or its more specifics. And trying to get databases that are flexible about saying, I want to know about prefixes that either cover or are more specifics of this range of addresses is a furry question that most relational databases just barf at you. Now, if you've got some source that allows you to make queries that not only give you the exact match, but give you all of the covering aggregates and any more specifics, let's talk, because that's really what's needed. That actually makes the rest of the work really easy. More, exact queries and more specifics only gets half the problem.
We have at some limit, with some limits, we are kind of a bit concerned on the load on some of these things on it, because as you mentioned, the queries are not that trivial there. And so we do it on some limited thing, but also back to like who owns I had to think a few times thinking, who knows which prefix is not easy to find out from databases either. I could probably go the same thing and see which prefix should not be announced at all. That might be slightly easier to, but even that is, still challenging. So it might be something for the future. Happy to talk more to you and there. So we are very open to feedback and like what features to add. As we have our own quite long list of things we want to add and make that a more useful thing. Thank you.
Thank you. Thank you very much for that talk. So now we have Anurag, also from Hurricane Electric, who is going to be talking about root servers.
Right, it works. Cool. Good morning, everyone. My name is Anurag, and as per the introduction, I work at Hurricane Electric, the same organization as the last speaker was. I'll be talking about something slightly different and related, which is about automating your IX route server config. If you have these things in place, you will eventually have less of the ASNs appearing in such reports, of course. Introduction about Hurricane Electric. We are a global backbone operator. We operate a backbone across all 5 continents, right now operating in around 41 countries. And as part of our efforts to promote internet exchanges, I'm volunteering for one of the exchanges in Mumbai. The name of the exchange is Bharat IX. Bharat means India in Hindi. And this is about the experiences of running the route server at Bharat IX, the challenges we faced and how we went around it in terms of filtering as well as automation. So I'll start with the slides. So how would you manage an IX route server in 2018? How many of people in the audience are managing an exchange? Can you raise your hand? I see a few hands. How many of you have an ASN and peer at an internet exchange? Not more. So at this point of time, you must be familiar with the models which are usually used, just going back to the quick basics, the bilateral peering and the multilateral peering. So you have bilateral peering where members connect to the shared peering fabric and create direct BGP sessions with each other, so bilateral sessions. It works, it's easy, except that in large exchanges, it gets hard because now you have to manage lots and lots of BGP sessions. So if you're an ISP who is joining one of the large, exchange like any of the European exchanges, you'll get into trouble in terms of creating lots and lots of sessions with all other members. So for that, the multilateral peering helps. In case of multilateral peering, you stay on the same shared peering fabric, but do have a BGP session with the route server. You learn routes via route server, and the next hop remains the same. The traffic flow remains exactly the same as it would be in case of bilateral peering. The only difference it creates is that it helps in scaling up, and it's a common practice for various networks to have a mix of multilateral peering as well as bilateral. You'd peer with route server, get all the routes, and then would also set up direct BGP sessions for resiliency with the key peers you think based on the traffic profile. So what a route server does, it exchanges the route without modifying the next hop, and this is important. I heard from a lot of people around asking me, what kind of hardware should we use for route server? And frankly speaking, it doesn't really matter because traffic never flows from the route server. I'll come to it in later stage, but as a quick point, we do run 2 route servers, and one of them we just run on a very small device, Intel Nuke, maybe a $200 device, and it just works fine. It works as good as a big fat server. It is often desired that internet exchanges share the routes transparently without adding their ASN in the AS path. The logic here is that you are not adding up your ASN and increasing the length of AS path because traffic is not flowing via you, it's just flowing via the switch. By injecting your AS path in the length, you are unnecessarily making the AS path longer and causing a problem that routes may not prefer going via exchange. This is a practice which is there in some of the large exchanges. It's there in one of the large exchange in India, which is Nixie. It's also a practice used in HKIX, if I'm not mistaken. It's still there. AS4635. We see that a lot in the BGP table. Often desired, the third feature, which is that route server does the route filtering, and this has problem. In past, it was very hard to have full-fledged filtering on the route server because how would you build the filter? In terms of filtering, there are 2 challenges, and I say that both as one of the network operator and as someone who is volunteering for the exchange. How would you build out filters at regular intervals? How would you do that on dynamic basis? And the second part of challenge is how you push that to your routers. You don't want to do that once in a week. If you start doing that in a week, you'll have serious challenge of various of users complaining of routing not working. So you need a mechanism to generate right filters. You need a mechanism to push those filters at regular intervals, probably something at max within 24 hours. The fourth desired feature, which modern day exchanges are often desired feature, which is about offering BGP community support. BGP community, as you may have learned over time, is just the tags, and based on those tags, you can perform certain actions. It's always good to have community support in exchange with certain key features like controlling the route propagation. And this is also important for various large content players who use Anycast, where they want to control the route propagation and they do not want to essentially just peer with a route server and take the route announcement further without any possible control. I come to the 2 challenges out of the last list. One, how you generate filters and push them, and the other part is how you give BGP community support. One point I want to add in case of BGP community support at the route server is that traditionally we always had route servers where we were doing inbound filtering to an extent. For the outbound, the route maps used to be common across all peers. If you have 10 members of route server, essentially everyone is going to have same policy on the export, which was followed traditionally. But if you are trying to offer BGP filtering with features like do not export to this peer, just tag a route with, say, a specific tag like 0:123, and in that case, do not announce the route to 123. For such scenarios, you need separate export policy for each peer, and this is where it gets very challenging. It does not scale if you are generating that policy by hand. solution. So we looked at different possible solutions. We are operating in non-for-profit fashion, so we wanted to stick with open source. We wanted to stick with as low cost as possible, and we figured out one way out is IXP Manager, very popular tool, but quite loaded. We do want to come to a point where we start using IXP Manager, but at this point of time we do not, and we keep on reviewing it at active intervals. So we went with the other option, which is a route server project, and that's the name. It's just A before the route server. It's an open source project. It takes care of the route server configuration. It offers you to generate config for two popular routing daemons, Bird and the OpenBGPD. Right now at our exchange, we are running two route server, both on Bird, but at some point we would explore using OpenBGPD for the software resiliency. It does not support other route servers, like, say, if someone is using a physical route server like Cisco or any other hardware vendor, or even if someone is using Quagga. So you may want to keep that in mind when considering a route server. So how do you use it? It's a package, you set it up, you initialize it, and then you add peers details in the client's YAML. It essentially operates with a YAML file where you define your peers in YAML-like config, which is a very easy to read config. You do not log into Bird and make changes because that's hard and that does not scale up, and that can always have problems in terms of one making mistakes. Based on the client's YAML and the initial config which you have given to the route server package during initialization, it will generate the route server daemon config, and it can do that based on a call. So you can essentially do that call manually by calling those scripts, or you can just set up something like a cron job to do this at regular intervals and make sure that it keeps on generating the route filters. It has an option to check the config before publishing it, so it can do configure check if you're familiar with that in the Bird, and ensure that everything is okay before it actually configures, and then it can push it, which is essentially means the configure command for the Bird. I'll go with some quick commands. So on a Debian-like machine, so in our case, we are essentially using Debian a lot. We use Proxmox for our as the hypervisors running these virtual machines and containers, which is all based on Debian. And most of the servers we have deployed, they are based on Ubuntu. So you do the installation of Python and Python 3 dev, and then you also need to install BGP-Q3. I found it a bit weird that the installation instruction do not really include BGP-Q3, which is it causes problem when you install. BGP-Q3 is again an open source package which can generate configuration for filters, and it's a very good package. It can generate configuration for filters if you're using, say, a Juniper or Cisco or a Bird, and it also has the option of putting your own syntax. So even if you are not running an exchange, just running a network, you may be interested in exploring BGP-Q3 for things like automating the filter generation. You install the Python pip and virtual environment, and then eventually you can get it working. And then eventually with the pip install, with the Python, you just install the route server. As soon as you install, you need to configure it. The configuration essentially include mostly the one-time parameters which you need to provide, like the router ID for the route server, the prefixes you are using internally, and things like the AS number which you intend to use on the route server. Here is an example of clients.yaml. Is this working? Can I get a wireless mic?
Perfect. So here's an example for the clients.yaml. This is essentially where you define, this is where you essentially define your clients. The logic here is that it should be extremely easy to read configuration file. It just includes the AS number, AS set, which you can include here manually. If you do not include any AS set, the tool has default integration with PeeringDB. It's going to pull the AS set out of PeeringDB if it exists for the network. At this point of time, we essentially
have email templates where we ask all our members for their AS set and we manually hard code it over there. We had experiences of outdated peering DB entries and those causing problems. So we decided not to automatically pull it out of peering DB and just hard code it within the clients.yaml. You have the option of defining IP, so you define the IP right over here. You also have option of defining multiple IPs. So we do have content players who ask for 2 different links from day one, and with 2 different links, I mean essentially 2 ports, all L3 going to their different routers. So you can define their IPv4 and IPv6 all within the clients.yaml file. It also supports additional options like defining certain prefixes if you want to by hand, although we try to avoid that practice, and we always ask our members to update their route objects in order to make sure that we filter them well and make sure that they have those associated with the ASN. Here's an example for generating of the route server config. You give a route server bird, you give the IP version 4, and the output location for the file. So in this case, we have used where the bird configuration file is located. I do see a typo here. It should be bird 6, but anyways. For the other one, you give IP version 6 and do the output, and it goes there. You can generate it at other location if you want. You have the option of running the tool at a server different from the route server itself. At this point of time, we are running it on the route server itself. We did explore the option of running it separately somewhere, because essentially right now we have a challenge where we have to sync up the clients.yaml file between both of our route servers with a regular rsync. If we run a package outside, it cannot generate the route server config for both of our route servers because both of the package are independent and have different router IDs for the route server. So essentially, it's about running 2 packages, whether you run them on the route server itself or whether you run them outside and somehow push it. The other important reason for running it locally is to make sure that we have a cron job in place. When I mention of the cron job, please be careful when you're using it. Be careful that you have checks in place so that you do not end up in the cron job running and breaking up the route server. So you can have the cron job in place where you generate a file, where you generate a config, you do the checks, and you just push it to the route server and ask the bird to accept that newer configuration. Why would you want to do that? It's because networks keep on adding further customers. So we have at this point of time 4 eyeball networks and 3 content networks. Out of those 4 eyeball networks, we expect them to add more and more downstream customers over time, as well as do things like getting more addresses, announcing more addresses. And because of the cron job, it ensures that whatever change they make, whatever customer they add by adding it in their AS set and having a valid route object, it automatically gets into our configuration without any manual intervention. So that offers us to do full-fledged route filtering for each of our member. We do not need to do anything of sort of like denying certain important prefixes and allowing everything else. We just allow all the prefixes of those members. We do have certain AS path filters in place, which come as a part of the A route server package, where it has hard-coded transit-free large ASNs, and the recommendation for the smaller exchanges remains that you deny those large ASNs in the AS path. So if we see any of the large ASNs, whether it's AT&T or Verizon or Telia or Entity, in the AS path, we are going to deny it at the exchange because we do not expect any of those routes to be the legitimate ones. The other part of the package is the BGP community support, and this again is very important because more and more content players have now got into a policy where they have started connecting to route servers. Earlier, many of the content players and certain large network, including Hurricane Electric, were not peering at the route server because you lose the ability to control your route propagation.
you may not want to carry routes beyond certain points. And if you're dependent completely on the route server, you lose that ability completely. The only way to fix problems in such scenarios is to shut down the route server session, which can have a really high impact on the network. So with the BGP community support, you can offer a certain control, and the A route server package comes, it comes with it, and the default communities are good enough at this point of time for most of the exchanges. Here is a sample of the BGP communities which we are offering in Bharat IX in Mumbai. And these communities, as well as this page, is automatically generated by the package. So nothing in return except the title of this slide here. It's just a page generated, and we can have that embedded in the site very soon. So one of the communities is 0 colon the ASN. So you can define the ASN. As soon as you have 0 colon the peer AS, the routes will not go to that AS. You can always have options like prepending, so you can prepend once or twice. You can also have options like adding no export to peer or no advertise to peer. In our experience, it is usually good enough for almost all large content players, including the players which use Anycast, where they are always worried about route propagation going beyond a point and breaking the Anycast network. Why we deployed it is also one of the large content players which is peering at our exchange. As soon as they showed up, they asked us for the community to deny the export to certain ASNs. And at that point, we realized that it is going to be extremely hard, because at that point of time, we were running 2 route servers, one on Bird, and for software resiliency, we were running one on the Quagga. In order to achieve this by hand, you essentially need to offer a specific tag to that specific peer. So I would say, if I have 6 other peers other than the 7th peer, I would generate the static tags. I would say, if you tag me with 0 colon peer 1, 0 colon peer 2, I'll make sure that it is there in the export policy with denial, so that the route does not go there. Just doesn't scale up. And speaking of the scale, one of the interesting things we noticed when we deployed this project is that the configuration size is huge with the route server. Even in our exchange with the 7 peers, the Bird config at this point of time for IPv4 and IPv6 is anywhere in the ranges of few megabytes instead of few KBs. And we learned over time it's totally fine. There are exchanges running Bird with as large as 50, 60 MB worth of config file, and it should be fine with the modern compute power. Some of the other key features which are worth mentioning: it supports out-of-box support for ROAs. If you are interested in RPKI, do consider using it. At this point of time, we do keep an eye on the ROAs. We are not taking any action, but I think we'll soon start rejecting the routes where we see invalid ROAs. Of course, for a small IX running in Mumbai, I don't see a large value at this point of time, but I don't see any negative point in doing it, so probably we'll be doing it anyway. It does have support for graceful shutdown for BGP sessions. That is under consideration, I believe, at this point of time, and that offers signaling of graceful shutdown for the sessions for reasons like maintenance and prevent cases where you can black hole traffic. It has integration with the peering DB for pulling asset, as I mentioned. It has option of integration with the IXP manager. And of course, I wonder, anyone in the audience, is anyone using IXP manager at their exchange? Can you raise hand? Anyone of you explored IXP manager? Okay. Maybe you can come up during the Q&A and share your experiences about the IXP manager. Would love to hear that. In our case, because it's an open source project, we want to use that, and it seems like a good package for not just configuration, but also for keeping a track of who you are connecting. But at the same time, we found the design of the package to be very bulky with the information it needs to bootstrap and the amount of effort it takes to maintain all the packages which are all the modules modules which are part of the package, including, say, Looking Glass or MRTG and so on. Speaking of MRTG, we do not have anything for graphing. What we do is we have an NMS in place which does graphing as well as monitoring. So we use an open source tool called LibNMS, one of the forks of Observium, and that generates all the graphs for all our equipment. That also generate graphs for things like power, optical power in a SFP, and we do have alert rules in place. So if we have optical power dropping significantly, or if something else goes down, it immediately sends an alert via to our Slack channel as well as on email, depending on the type of alert. Another important feature it offers is full IX config generation based on the peering DB record. This is very, very useful feature. If you are running an IX already, and if you have a reasonable number of members, you may be worried at this point of time about doing it from scratch. So if you have an IX, you can point the package to the IXP manager, to the peering DB record, and it would generate the config needed for your IX route server automatically. And that's very useful. If all your peers are on peering DB, and they have mentioned that they peer at your IX, you can probably set this up in less than 15 minutes. It also has support for Ansible role for configuration on the playbooks, and we do intend to use that. We are partially using it at this point of time. The reason why you want to you may be interested in the Ansible role is because then you can always define the peers in YAML-like config in an Ansible playbook instead of the client.yaml, which is for individual servers. The advantage it gives you is that you can have it in the playbook and push it to both or maybe multiple, more than 2 route servers, and it helps in making sure that the sessions are all synced up across both route servers. Some of the references, of course, the A route server project, open source project. It's a great one. It's there on the GitHub. You can find the link there. Unfortunately, there's not much documentation on GitHub for that. You may find the link on readthedocs.io, which apparently seems like the modern way of putting documentation. So you can find all the documentation associated with the project here. You may be interested in looking at the Ansible role, which is given over here. If you're running Ansible or if you're exploring Ansible, makes things extremely easy, and you can have a serious amount of orchestration by just defining various actions in the playbook itself, including peer addition. The IXP manager, of course. If you're running a large IX, go ahead and explore. It seems like a good option. And of course, Bharat IX, our website, which is still under development, and I won't recommend looking at it as the prime source of the data. We're still fixing some of the pages at this point of time. That's about it. Any questions?
It's always a hard gig taking the slot immediately before lunchtime. Everybody wants to eat. We have one. Please state your name at the microphone.
I am Brajesh Jain. The question I wanted to ask that in the automatic routing, when the port becomes full, what happens? The route swapping takes place, or how do you take care?
So for any scenario where a port gets full and congested, you can have scenarios where ISPs take action manually, or you can have scenarios where there are large content networks like, say, Facebook, Google, or Akamai, who may redirect traffic through other sources in order to make sure that they optimize the end user experience. By default, it is not something which is supported at the BGP level to read out things.
No, ISP, of course, should take care, but what would IXP do in such a case?
So you are asking about a question, let's say if one of our members port is choking?
Yes.
We would essentially, so it hasn't happened so far. It would be an excellent problem I would love to have. But hypothetically speaking, if one of our members' port is choking, we would reach out to them and would request them for upgrade of the port. At this point of time, we are giving totally free ports. So if the same policy goes on, we would essentially offer them another free port and would request them to bundle both ports and have more capacity.
Thank you.
Thank you.
This is Shuman, now putting on my BDIX hat. And so you are filtering completely based on AS set. So no manual filtering or anything into your route filtering.
It's based on AS set as well as I mentioned, we are also rejecting routes based on the AS path. So if a route comes which where the origin AS as well as the prefix matches the AS set and the IRR config, but still has a pretty bad AS path, where we see some super large ASNs in place, we are going to deny it. Because that tends to happen in some of the IXs where you may start announcing indirectly learned routes. You may start leaking an indirectly learned route. We don't want that kind of scenario to propagate the route server.
So how are you filtering those actually? Is it automated or is it a manual thing?
It's automated. And there is a hard code list which comes with a package of the all top, I use this term loosely, tier 1 ASNs in place. Okay. You can always add the same. We did added the large Indian ASNs in that list. So if with any of our peer, we have Bharti Airtel, Tata, and Reliance Jio. So if any of our peer is announcing a route with their ASN in the AS path, we are going to deny the route.
Thank you.
Well, if we have no more questions, I think we're going to wrap up the Wednesday tech session early and everyone can go and have lunch. So please give a round of applause and recognition to our speakers, except we have one last speaker. No, I'm afraid I've closed the microphone queue. Remco, please state your name.
Hi, my name is Remco and I run an internet exchange, actually a number of them. Since you're here on stage and you work for Hurricane Electric, and we're talking about route servers. So interestingly, one of the biggest challenges that an internet exchange operator in the startup phase has to deal with is the bulk of the AS set that they get from Hurricane Electric. And actually to the point where most of your configuration, initially about 75% of your configuration is going to be Hurricane Electric route sets and continuous filtering of that. Is that something that you're looking at internally? Is there, I mean,
Excuse me, Anurag, which hat are you wearing? Are you wearing the Mumbai IX hat or are you wearing the Hurricane Electric hat?
I can wear the Hurricane Electric hat. I'm sorry, I couldn't resist. But I mean, I'm trying to sort of weed out the composition of your AS set. And to me, it looks fiercely complicated and it certainly takes BGPQ free almost forever to run through it. Is that something you're looking at? You would do the rest of the industry a massive favor if you did.
I am aware of the fact that our AS set is huge, and of course, one part of that is because we are the largest peer network at this point of time, and that's true for both IPv4 and IPv6. So we have over 7,400 peers in case of IPv4. If it's true whether the AS set may have ASNs which may not be peer, that is something we can always look at. So I'm going to take a note of this, and I'll definitely have a check of our peers. But remember, because of such large peering, we can always have scenario where some peer is down for a few months in some place. We cannot remove their ASN from the AS set. Plus, we may always have case where we are peering with someone over a route server, and we do not hear back from them if they are down or if they are out of business or that sort of. So it would not be a good case to remove their ASN from our AS set.
Okay, thank you very much.
Thank you.
Well, with 3 minutes to go, I can still send us all home for lunch early, unless there's anyone else who'd like to carry on the conversation, but maybe it's best done over lunch. So I would this time like to thank all our speakers for their presentations today and declare this session closed. Thank you.